All right, for example number 7, we have a bicycle wheel that has a radius of r. So let's draw us out a little bit of a picture here. So we've got our bicycle tire, and it has a radius of r. We'll put its radius in red. Okay, and then we want there to be a point P on the spoke. So somewhere along the spokes on this bicycle tire, we have a point P. That point P is a distance D from the center of the tire. Put that in purple. So this purple distance right here is the distance D. Now, just for informational purposes, I'm going to go ahead and finish that line out, and let's call this A, the value A. Okay, so now let's go ahead and draw this wheel on the x-axis, which is also the same as the ground. So the curve that is mapped out on this equation is this point P. Now this point P is given by, or this graph is given by the equations right here, these parametric equations. X of theta is equal to 17 theta minus 9 sine theta, and 17 minus 9 cosine theta for y. You could map those on Desmos and see what the graph actually looks like for those also. But really the only thing that we're interested in, we're really only interested in the equation y, because y is going to give us all of these y values. So by looking at what happens with this equation with y, we can figure out all of this information. So first of all, what we want to know is we want to know what is the highest point for y, and we want to know what the lowest point for y. Because at the lowest point, that's actually going to give us this value A. At the highest point is going to be right here, which would be the distance. It would be the same. This A distance would be the same up here. Okay, so we would be the same distance away from the center. So if we knew this highest distance, we could figure out what our radius is. It's going to take a little bit of work. It's definitely more than a one-step equation, but we can work with that. So what we want to know is what is the lowest and the highest value y takes on. So let's look at this cosine theta. The lowest and highest values that cosine takes on is 1 and negative 1. So notice I'm not looking at the amplitude, that 9 value there. Only want to know what happens with cosine theta. So let's see what y is if all of the cosine theta part equaled 1. If that all equaled 1, we would have a value of 8. If it equaled negative 1, our negatives would cancel, and we would have 26. So that tells me what the highest and lowest points of y will be. So that tells me right here, the lowest point that P will ever be will be a distance of 8 units from the ground. That gives me my A value. Okay. The highest that it will ever be is 26. So that 26 encompasses all of this information here, all the way down to the ground is 26. So now let's look at what would be just between the two values of P. So I just want to know now, what is that distance? So if I know 26 goes from this point down to the ground, I can just subtract 8 and get the distance between the two P values. Okay, so 26 minus 8 would be 18. Okay, then 18, right in the middle of 18 is our center. So I know if I take half of 18, that will give me the distance of D. So D is going to equal 9 in this case. Then we need to figure out what our radius is. So our radius is going to be equal to d plus a, which we already found d to be 9, and we know that a is equal to 8, so that is 17. So 9 and 17 are the two solutions, or two answers that we need for that point.